Okay, so here is another attempt at understanding how the Kubernetes services work. So yesterday we said, okay, let me get back to my favorite pen here shortly. Okay, so we said services are key to how pods or containers talk to each other. So if I have a container C1 and he wants to talk to container C2, we don't want them to be talking directly to each other. And the question is why? 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 Why do we not want C1 to reach out directly to C2? Um, the answer to that question is, um, the containers are lightweight and can come up and go away at a moment's notice. Remember, our key note yesterday was that the state of Kubernetes cluster is very dynamic. Remember that? Why is that dynamic? Well, it's dynamic because the person or the system that is controlling the cluster is responding to real life events. Okay, so that means that if I have some sort of a disciplined way to, always, reach out and have the containers connect each other, it is better for me. And let's imagine how so. So instead of doing it this way, if we say I've got a whoops, didn't mean to do that. So I've got a container C1. Maybe it get a little bit bigger. So if I've got a container C1, okay, and if I introduce a intermediate party called service that I'm abbreviating as SVC, and this service reaches out to C2, then the benefit I have is that if the manager of the controller of the cluster decides that they want to run more copies of C2, or then that change is not really visible to me, right? So they could be like this area of my cluster, sorry, these pods could be running on worker node 1, and there could be 3 of them, right? Or the state of the cluster can change in response to a real life event. And maybe this doesn't really respond here anymore. Maybe this is no longer the picture of the cluster. Maybe there is only one copy of C2 running now, and it's not running out of worker node 1. It's working out. I mean, it's running out of worker node, let's say 4. And by having this redirection, by having this intermediate party of service in the middle, we are allowing C1 to always say, hey, you don't worry about where C2 is running. You don't worry about what happens to the party you're talking to, which node they're running, and what their IP address is. You're just worried about, where the service is. And so long as you know what is the service IP, right? That's all you really care about. And something else will, take care of getting you there. Something else will make sure that you find the party that you're wanting to talk to in the cluster, where they're residing, and what their current IP address is, and which machine to go to. That's something you don't care. C1 is our first container, and they only care about talking to the service. The service in turn turns around and make the system work. Now the question is, how does service know what is running where? Because if you look back at our picture of the cluster, right, we've got a master node. That's where that's where the main master components are running, which are controlling the worker nodes. The worker nodes is where the applications run, and master nodes is where the controlling part or the management components run. And the question is that when the call goes from the master node to the worker node and say, hey, please schedule a pod or please terminate a pod, how does service know that all of these changes are happening? So there's a really good blog post that I found out that I'm going to link in the comments below, but I'm going to create a small picture that shows you how that's supposed to work. Okay, so when and this is described very well in the blog that I'm going to list here. But what I see them doing is basically something like this. So you've got a worker node. Well, let's do a worker node in yellow. So you've got your worker node. Let's say this is worker node one, and you've got your master node. We've always drawn that with We've always drawn that with our purple thing. So this is our master node one, and this is our worker node one, right? So this is our worker node one, right? And let's say we have another worker node here for worker node two. Well, what ends up happening is when you deploy an application, okay? When you deploy an application, there is this concept of um, a liveness probe, okay, and the readiness probe, okay. So when the kubelet, remember the guy, kubelet is this, there's a door, right? Think of a door in the front of the room, right? And then think of two people standing here. One is called kubelet. Remember, kubelet is something that lets people come in, right? That's why we call them kubelet. And then the other party standing here was kube proxy, right? And so um, when we have an application deployed, sometimes it takes them a little while to get ready before they can talk to anyone, right? It's kind of like if you go in and check into a hotel and you're there to meet someone, you don't want people to come, seeing you in your room right away. You want them to give you a little bit of time to get ready. That's where the readiness probe comes in. That basically says, hey, what can I ping on this app to make sure it's ready to talk to other people, right? Because remember, our use case that we're trying to learn is I've got a orange app over here, and they're trying to reach out to this. They're trying to go talk to this thing, right? And I can't do that directly, but I mean that's what they're trying to do. So what happens is that on every at every pod level, there is this concept of a readiness probe. So let's just say question mark, are you ready? And question mark, are you there? And things of these is like, some sort of a check, some sort of a flag, whatever you want to call it. Basically, it's just a ping that is created at the um, pod level, which basically says, "Hey, should I be sending traffic here?" Right? So if the answer is yes, then Masternode is sort of keeping that copy and identifying, which pods are ready to take traffic from other pods or externally from the cluster, and which are not. Right. So when the orange pod wants to talk to the purple pod, basically before that call can happen, um, the readiness probe on the purple side needs to tell Kubernetes that, by the way, I'm ready. I'm spun up. So in a real life app example, let's say that you created a cluster. Sorry, you created a pod, and then during the initialization of the pod, you needed to go and establish a database connection, right? So imagine this is a Tomcat pod, Okay, so this is like a Tomcat server, and it's got some, Java code. It's got an embedded server in it, right? And it needs time to initiate a connection to some database. Okay, and let's say that this connection takes around, well, let's do 100 millisecond. So in this 100 millisecond, when you schedule the pod for the first 100 milliseconds, I don't want anybody talking to me because I'm getting ready. I'm still initializing. So the readiness probe for 100 milliseconds should return, whoops, the readiness probe as the time goes by. This is 0 millisecond when it's created, 50 millisecond, 100 millisecond, 150 milliseconds. So as the part is initializing, it may say no, 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 not ready, not ready, and then it'll say yes, ready, right? So it'll say no while it's initializing, whoops, no while it's initializing, and yes when it is ready to take on traffic. So once that happens, the kubelet lets the master know that, hey, by the way, you can let these other guys know, how to route traffic. So what I mean by that is there are two conversations happening here that are important to understand, okay? So the first conversation that is important to understand is oops, sorry, the master node is talking to the kubelet, okay? And the kubelet is talking to the master node. Okay, so there's a bidirectional between, the agent on the worker node, right? So this is happening on the master node, and this is happening on the worker node, right? There is a component here called API server, and then there's a kubelet over here, and they're talking to each other. The master saying, hey, please schedule this pod. Please do this. And then the worker said, yes, sir, it's ready to go. You can start sending traffic, right? So there's a bidirectional communication happening there. And there is another communication happening between master node, and kubeproxy, okay? And the kubeproxy is basically talking to something on the node. Okay, so master is telling kubeproxy, by the way, somebody's ready. We've got somebody ready to, take the call. Um, you can go ahead and start sending traffic. Okay, so remember, kubelet is something that is largely concerned with scheduling the pods, terminating the pods, creation, okay, of the pods, deletion of the pods, and letting people know when things are ready. Okay, so that's what their job is. There's just this one agent that's running on the worker node and doing that. The job of the kube proxy, remember that it's a network proxy, and whenever we're talking about networks, we're talking about things networking to each other. We're talking about things talking to each other, and what that means is basically master has to let somehow these worker nodes know that, hey, I've just scheduled a pod on one of the worker nodes, right? So let's say I've got this master node here, okay, and I've got two worker nodes. So I've got worker node 1, worker node 2, right? Let's say that the master reaches out via an API call. Okay, there's an API server and it reaches out to this worker node and say, hey, please go ahead and run a application pod. So it does that, okay? Application pod. Now somehow this news need to get here, right? This news of, hey, I've just scheduled this news of hey, I've just scheduled a purple pod on one of the worker nodes needs to be somehow communicated across the cluster. And the way that happens is basically what ends up happening is that the master node then updates the 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 queue proxy here, and the queue proxy is the network piece. Okay, so it's the network piece, and the queue proxy then um, is updating another component here, which is local to every machine, and that's typically what we call IP tables. Okay. Okay, that's how that works. So two communications are happening. The first is between master and the kubelet, and that's for creation and deletion of pods. When that happens, the kubelet sits there and waits for the pod to indicate that it is ready. How does that happen? That happens with what is called a readiness probe. And when that readiness probe says, yes, the pod is ready, then the kubelet lets this thing know to the master. So that's in step number one. Step number one is right over here. So in step number one, the master is letting kubelet know that, hey, please go ahead and create a pod. Okay. And step number two, the kubelet lets the master know that the pod is ready. So in our first thing, we're going to say create pod. That is the request, okay, in our first call. The second call, we've got the kubelet that is letting the master node say, hey, you asked me to create a pod. Pod is created and it is ready, okay, and it is ready. So it lets that know, and then the master says, aha, I have just scheduled something on one of the worker nodes. I better update all the queue proxies on all the on all the worker nodes so that this news of a new pod being created on a worker node is known by all the pods across the cluster, right? Remember, the key concept here is that the Kubernetes clusters are very dynamic or are meant to be dynamic. What does that mean that they're meant to be dynamic? The pods can come and go at any time, which means that the picture, the state of the cluster, it changes from minute to minute and potentially even second to second, which means that whenever something is created on one of the worker nodes or deleted from the worker nodes, we better let all the other machines know in the cluster as well, so everybody is on the same page, right? That's the idea. Now, there is one thing that we haven't talked about that I want to maybe delve a little bit more into, which is this idea of IP tables and whatnot. So, a Kubernetes service can be using one of the three modes, okay, to do its thing, right? What is the thing it does? Instead of talking from one container to another container, and by the way, notice that I've been using the word pods and containers somewhat interchangeably, but we'll talk about what the difference is. But right now, let's say one container wants to talk to container two. We want container one to talk to service, and the service to help find out where the container two lives. Okay. But in order to do that, there are three ways it can go about doing it. And those three ways are user space mode, the IP tables mode, and the IPVS virtual server mode. Okay. This one typically is no longer favored, so I'm just sort of gonna like just maybe just cross it out a little bit. Okay. This is runs in the user space and no longer favored. IP tables is what is generally used in most of the clusters, okay? And IPVS is sort of the new kid on the block, okay? And it's got some additional features of how things happen. Now the question is, what is this IP tables? Well, IP tables is a firewall around a Linux server, right? So remember our worker nodes, these yellow guys, we've been calling them worker nodes, worker node 1, okay, and worker node 2. We've been calling them nodes, but really they are node is the same thing as a computer, which is same thing as a server, which is really, typically in Kubernetes, a Linux server, right? And, typically is also a virtualized Linux server, right? Virtualized Linux server. So you can say that this is just a VM, right? But on every VM, there is sort of like this boundary around it that you can kind of think of, which protects it from, you know, sort of like a firewall right around it, which says, hey, who should I let in and who should I let out? Okay. What should I let out from, what kind of packets, what kind of network traffic should I let into this machine, and what kind of network traffic should I let out of the system? So that is, it's a basically a firewalling kind of a system. And in order to do that, well, now it turns out that if you're going to run multiple copies of our application as different containers, right? Well, I'm going to run container 1, container 2, container 3, container 4, and they're going to come and go. And I want these purple containers to come in and get traffic. I better let this IP table guys know, right? Because they are responsible for firewalling the Linux server. So what happens is when the master, remember in our conversation, there were two things going on. The kubelet was letting the master know, sir, the pod is ready, go ahead, start sending traffic to it. Then the master was turning around and asking Kubernetes to say, sorry, proxy to say, hey, let's go ahead and update everyone. Let's spread the news around that we've got this new thing scheduled. So the way that actually happens is that on every worker node there is a set of IP table rules that run, and the way the kube proxy does its thing is basically the kube proxy updates the IP table rules that basically dictate how things move in and out of the Linux server, right? So the kubelet was letting the master know that, hey, I've scheduled the pod, it's ready, the readiness probe is passing. The master turned around and asked the kube proxy to update the service data and say, hey, please go ahead and update your IP table rules so that, these communication between pods on different machines or potentially same machines can start to happen. So that's basically the idea. You can see as a recap that the main idea here is you've got basically two main interactions happening. First, when the pod is created. Second, when the kubelet knows the master that the pod is ready. This is done through a readiness probe that is created, and then when the readiness probe passes, the kubelet lets the master know that, hey, the pod has not only been created, it's also ready, right? It's ready to go. It feels like the camera is set up right. It's all in the right shape, and it's ready to for the public or other people to come talk to it. Then the master says, okay, fine, let's let everybody on the other worker nodes know, and that kind of talk thing happens between master and kube proxy. So keep in mind that the kubelet's job is the creation and deletion and letting know that the pods are ready or not. And then the job of the kube proxy is basically to keep all the service magic happening. Um, uh, you can say that kube proxy makes the concept of Kubernetes services work. Okay, and they run in one of the three modes. There's the user space mode, which is typically not used for a variety of reasons. The mostly what is used is IP tables, and then the third one is IPVS. Now, last thing I'll say before we wrap up is just like a readiness probe, something else can happen, right? So imagine that this worker node gets a issue, right? There's like a kernel panic or some sort of a hardware failure, or the hardware which is running this worker node gets to be no longer available. So then in that case, the well, let's not go there. We'll come back to that in the next section.